Well, hello. Welcome back from spring break. We left off on the Friday before spring break with Boyle's Law and discussing how volume and pressure are related to each other. And we did, or most of you did, A through F on the Google form. And aside from some significant digit issues, just about everybody got 100% on all of those questions. So I feel like you've really got that figured out. So I just want to review, just because it's been a week, that when we're looking at Boyle's Law, it's specifically looking at volume and pressure. The units that we're going to be using for volume could be any of these: liters, milliliters, centimeters cubed, or meters cubed. And I want to remind you all the way back to the beginning of the school year when we talked about how you could convert between centimeters cubed and milliliters because they're a 1-to-1 ratio. They're an equality. They're equal to each other. Okay, so those are our units for volume. And we also discussed pressure units. We talked about how there's some other pressure units, but we won't really be using those. We're mostly going to be using atmospheres and kilopascals. And when we did take our notes, I don't know if I had quarantine brain or what, but I wrote that down as kilopascals when in fact it's an O here. So that's kilopascals. And then we went on to discuss the basic setup of the equation, which is P1 times V1 is equal to P2 times V2. And our first job is to isolate the variable we're looking for. And we do that by simply moving the variables to one side of the equation that we're not searching for and solving for the one we are. In our first problem that we did, we looked at these numbers here. And so we plug those in. And we did that just by looking at the chart, which makes it pretty easy. It's just telling us, okay, this one's P1, this one's V1. So we just plugged the numbers directly in and we got our answer. So pretty easy. And as you guys have shown me through the Google form is that, yeah, it is pretty easy. You can do this stuff. So you were to do 1A through 1F over the break or on that Friday. Most of you accomplished it on Friday. So what I need you to do is if you haven't completed those problems yet, you'll need to hop on it, get those done, because we're going to move on to the next thing. And I don't want you to get left behind in the dust, as it were. So we're going to go kind of slow today. And tomorrow we'll pick it up a little bit. We're going to do a word problem together, and I'm going to have you solve the additional 2 word problems on your own for homework. And then tomorrow we'll jump into the new law. So let's have a look here. When we're looking at our problem, let's see if I can zoom in. I can. This has markings on it again because this is an old handout, because I just pulled it out of my binder. You don't have to print the handout at all. If you don't have access to a printer, don't be thinking you don't have to do your homework, because you don't need to. All you really need is to be able to view it on a screen and then write it out on a separate piece of paper, because ultimately you're going to be pushing those numbers through on the Google Classroom for credit. Okay, so now we have a series of word problems, and that's the way this handout works. You're going to get some grid problems that help you learn how to set up the problems, and then 3 or 4 word problems that you're going to use to really practice what you've learned. So let's look at number 2 here. We have, and I'll go ahead and label it, number 2, we have a gas cylinder, and in that gas cylinder, people in ASB, or if you've ever volunteered for ASB, knows what this is all about. You've got, let's say, a gas tank, and you're filling balloons. So you have this gas cylinder, and it's going to have 0.722 meters cubed of hydrogen gas inside of it. 0.722 meters cubed of the hydrogen gas, and it's at a pressure of 10.6 atmospheres. All right. And what we're going to do is fill a balloon, and if your pressure in the balloon is 0.96 atmospheres, then what is the volume? So that's essentially what's being asked of us. And even if you didn't draw a picture to show what we're doing, you could do something in the line of a grid. We know all of these problems that we're working with here with the Boyle's law are going to follow the same basic problem, which will be P1 times V1 is equal to P2 times V2. Every single one of them. So that's what we're looking for. We're looking for P1, we're looking for V1, we're looking for P2, and we're looking for V2. And we could construct on all of these sort of a data table that is saying, okay, we've got P1, V1, P2, and V2, and we're looking for those. And I'm not saying you have to do this. I'm just saying if you're feeling uncomfortable and you want to settle yourself a little bit, this could be helpful. You can skip this and just go ahead and plug in your numbers and solve. But if you're having trouble, this would be a good way to sort of settle yourself and get yourself used to the problems. So we've got P1 and V1, and that's something we're going to have to put in. And oftentimes the question comes up, which one of these is 1 and which one is 2? Well, as it turns out, it doesn't matter which one you decide is 1 and which one you decide is 2. You just have to pick the two that are together. So I'm going to choose these ones because they came up first in the problem when I was reading as conditions 1. So I'm going to say that's number 1. And then inside the balloon, I'm going to say is 2. And what do I mean by that? I mean that that's 2 and that's 1. So I have a pressure one is 10.6 atmospheres. And a volume one is 0.722 meters cubed. And here in conditions 2 over here, I have a pressure 2.96 atmospheres. And I'm searching for my volume 2. So that's my unknown. Okay, we've made a lot of progress now because now we know exactly what we're dealing with here. We need to solve for this dude right here. And that means this one has to move out of the way and join these two. So I'm going to go ahead and rewrite P1 and V1 like that. And I'm going to leave P2, I'm going to leave V2 where it's at because that's what we're solving for. And P2 is going to move down. Because I moved it over the equal sign, I needed to flip it, as it were, and put it down here in the denominator. So now that I have my base equation all set up, I can plug in my numbers and solve. So I'll go to 10.6 atmospheres, right, because that's P1. And V1 is 0.722 meters cubed. And then I'm going to divide that by P2, which is 0.96 atmospheres. All right, and all that is going to equal V2. So grab your calculator and turn it on. I hope you have your calculator handy. So we've got 10.6 times 0.722. And then we're going to divide that by 0.96. And we get an answer. And it is 7.97. and that would be volume, so it's meters cubed. But 7.97 isn't a good answer because when I look back at my significant digits, I have 3, and I have 2. And remember, I can't report any more significant digits than I have. So I'm going to go ahead and round this off to 2 significant digits. So that means that V2 is going to be equal to 8.0 meters cubed. And that is the real answer. Okay, so your job now for the rest of today and before tomorrow is to do 3 and 4. So do 3 and 4 on the worksheet. You know, you're going to do the thing and then fill out the Google form. And that's it. And I really do want you to get this done before tomorrow because tomorrow I want to move on to the next law. And so I think that would be something that you can handle. It's only 2 problems. And with the success you had on the other ones, I'm sure it'll be fine. I feel confident. If not, send me a message and I'll try to help you. Maybe if you're totally lost, we can do, you know, more of a FaceTime thing or something. So be aware that we do have options. We can get through this. We are tough. We are strong. We are chemistry. And I will see you tomorrow. Y'all have a good evening.